This video is going to look at pulling together a lot of the things we've been working on in Trig and Pythagorean theorem, using these to solve for unknown sides or angles in right triangles. So I'm going to go through about 5 examples here just very quickly to give you an idea of how to work these problems. Let's start with this triangle ABC. Notice that all we really know is it is a right triangle. We have an angle measure of 61 degrees and a side of 4. Now, since this is not a 30, 60, 90, we can't use our special triangle relationships. Here's what we can do, though. We're trying to find AB. In this case, we're going to write it as a decimal to the nearest tenth. So we want to find this measurement up here. Well, we know this angle measurement. We're trying to find the opposite side, and we know the adjacent side to it. Opposite and adjacent, we can use tangent. So the tangent of 61 degrees, which is just the tangent of that angle, is equal to opposite, x, over adjacent, 4. We need to do a little algebra to get x by itself. We're going to take both sides times 4. So x is going to equal 4 times the tangent of 61. Be very careful that you do not take 61 times 4. This is the tangent of 61. Think of it like there has to be parentheses there. We have to keep that together. At this point, this is plugging it into your calculator, and I'll show you real quick. All we do is do 4 times the tangent of 61. And that's all we need. Close our parentheses. If we hit enter, that's going to give us our answer. There we go. 7.216. We want to round it to the nearest tenth. So x is equal to 7.2. That's going to be the distance from A to B. Let's go to the next one. All right. Here we have triangle KLM, and we want to find the measure of angle M. And we're going to round that to the nearest degree. Well, we have angle M up here. We don't know what its degrees are. But we do know the opposite side measure and the hypotenuse measure. We have opposite, hypotenuse. This calls for sine. So the sine of angle M is equal to the opposite over the hypotenuse. Okay? To find the angle measure here, we use our calculator, we use our inverse sine function. So let's do that real quick. We're going to plug in the inverse of sine, which is second and sine. All right? And now we're going to plug in, you could plug this in as 9 over 18. You could simplify it 1/2. You could plug it in as 0.5. It doesn't matter in this case. But you will find problems where simplifying it might make it much easier. All right? So we're just going to do the sine of 1/2. We hit enter. 30 degrees. So this tells us that angle M is 30 degrees. So we could write that in up here as well. Okay? If we were solving this whole triangle at this point, we would know that angle L is 60 without even using any trig. Okay? Just by angle sum theory. All right? And we could use our special trig ratios from our special right triangles to find Km if we wanted to. All right. Okay, here we have QRP. We want to find 3 different things: PR, QR, and the measure of angle P. Be very careful here. You don't have to solve them in the order that the program tells you to, or that the test or the textbook tells you to. It might be easier to solve the last one first. And in this case it is. We can find the measure of angle P in this case without using any trig. We know we have a right angle of 90 and an angle of 60. We can find P just by our angle sum theorem. All 3 add up to 180, so angle P has to be 30. In this case, we have one of our special right triangles, a 30, 60, 90. So we can use our relationships there to solve this one without our calculator. Remember, the relationship to the shortest side is going to be half of the hypotenuse, okay? The hypotenuse is twice the length of the shortest, so the shortest is half the length of the hypotenuse. So QR is 6. You could also set up your similar triangle ratios if you wanted to. If QR is 6, and I'm going to draw that in up here, the relationship of the smallest leg to the largest leg, we're going to take this number times square root of 3. So PR is going to equal 6 times the square root of 3. And I'm going to write it in both just so we have it. And we're done. We know all of the measurements of this triangle. Okay. IJK. Again, we want to find 3 different pieces of information. The order might be better to go from bottom to top, do the one in the middle. You just don't know. And there's not a hard and fast rule to that. You just want to look for maybe what's simplest. Now, where do we start here? Well, the first thing is we could find this side length using the Pythagorean theorem. A squared plus b squared equals c squared. And that's fine if you want to try to do it that way. The only reason I think maybe that would be a little hard is we've got a lot of radicals here to deal with. Okay? Again, though, if you want to try it, that's great. I'm going to do this one. Let's say I wanted to find the measure of angle I first. All right? So we're trying to find I. We know the opposite side, and we know the hypotenuse. So this calls for sine. So the sine of angle I equals the opposite, 2 over square root of 26 over the hypotenuse. All right. At this point, if you wanted to use your inverse sine function and punch it into the calculator, you could. But be very careful about the way you enter this in. If you enter it wrong, it's going to give you either the wrong answer or an error message. This is a good situation to maybe simplify here a little bit first. Well, we can simplify the 2 and the 4th very easily. We can divide out a 2. All right? Within these, since these kind of even out, we could divide here. 26 divided by 13, that gives us, we basically factor out a 13 of each. All right? So we would be left with 1 and 2. So all we have left, the square root of 1 is just 1. We would have the square root of 2 over 2. That will be much easier to put into the calculator. So I'm going to use my inverse sine function again, inverse sine, and I'm going to put in the square root of 2, then I'm going to divide that by 2, divided by 2. Close my parentheses and hit enter. And we get that it's a 45-degree angle. So we know the measure angle I is 45 degrees. We can now find angle J without doing trig. We can just use our angle sum theorem. If this is a 45, this must be a 45. IK. We could use trig again, but let's think of it on a more basic level. If this is a 45 and 45, this is an isosceles triangle. These two measurements are just going to have to be the same. So IK will also be 2 times the square root of 26. Okay? So about 3 different ways you could work things there depending on what you're most comfortable with. Okay? Let's go to the last one. DEF. We again want to find 3 measurements. This time we're going to use decimals and round to the nearest tenth. So, again, we're solving really for everything we don't know on this triangle. We only know it's a right, we have an angle, we have a side. From that, we can find about anything else. All right. So we have 24. We want to find DE, EF, and angle D. Well, we can find angle D again without even using trig. We can just use our angle sum theorem. D in this case is going to be 66 degrees. All right. I'm going to write that in up here just so we know we've got that solved. All right. 66 degrees. Now, it does not matter if we find DE or EF next. It does affect which ratio we use. So we have a 24-degree angle. Let's say that we're going to find this adjacent angle first. Adjacent side, excuse me. So we have an adjacent over a hypotenuse. Adjacent over hypotenuse means we're going to be using cosine. Do a little algebra here to take both sides times 5 so we have something we can plug into the calculator. And we plug that in. So I'm going to put 5 times the cosine of 24. All right? Right like that. Hit enter. And I get 4.567. We're rounding to the nearest tenth. So we're going to have 4.6 as our measure here. All right? Now, to find dE, we can do another trig function. We could do Pythagorean theorem. You've got a couple options. Let's go ahead, though, and simply use the sine of 24. That's going to equal, we're going to call this side y for right now, just so we use a different variable, divided by 5. So 5 times the sine of 24 degrees equals our y. I'm going to punch that in real quick. 5 sine 24. Right like that. Hit enter. And we get 2.033. We're rounding to the nearest tenth, so it will just be 2. Okay. Work the example problems. That's just a few examples to get you started.